will design local oscillator in such a way that for this positive DC signal, it should reduce the phase of the output signal. Now when I say it should reduce the phase of the output signal, it is right now at 90 degree. It will be reduced to some smaller value. Ideally it should be taken towards 0 degree. Now let us say if the phase correction has taken place and if the phase has become 0 degree, in that case A m of t cos phi will now become A times m of t, and A m of t sin phi will become 0 in this case. And if that happens, now this two input signals to phase discriminator will be reversed. 0 goes from the lower input and upper input is not 0 anymore, it is the signal m of t. So in this case, because upper input is non-zero and lower input is 0, let's say this time the DC output generated is negative DC. For the negative DC, we will design the local oscillator in such a way that it should not make any changes in the phase of the output signal, and hence phase of the output signal will be kept to 0 degree. So for any other value of phase between 90 and 0 degree, there will be DC signal generated between maximum positive and minimum negative values, and that DC signal will keep on changing phase of the output carrier signal. And this phase correction will keep on taking place till the time phase becomes equal to 0, output is minimum negative value, and the phase correction stops. So how do we achieve the phase correction, and how do we make sure that the phase does not remain at 90 degrees and always goes back to the 0 degree, is by having closed loop feedback system. So what we basically have is the closed loop feedback system. We read the phase of the carrier signal by comparing the outputs of two low pass filters, and based on the output signals we generate the DC signal and we let the local oscillator change its phase. And because we are comparing the two signals coming from two different channels, we call these channels as forward channels and quadrature channel. Forward channel will have the signal in phase with the original signal. That means this channel will use the carrier in the form of cosine function with ideally phase equal to 0, whereas the quadrature channel will use the carrier in the form of sine, which is 90 degree out of phase with respect to cos, and again the value of phi should remain 0. So in this case, if phi remains 0, as the final conclusion, my output comes from the first channel of the receiver, and the second channel output will be 0, and we simply use it to make sure that the phase of the local oscillators remains equal to 0 degree. So that's how in Costas receiver we overcome the quadrature null effect by using a block of phase discriminator.